So today we are going to discuss about the action spectrum as we have discussed the absorption spectrum. So action spectrum is also known as angle make spectrum. This is also known as angle make experiment. Angle make experiment like action spectrum in which we're gonna graph which is plotted to check the effectiveness of light absorption, like which pigment is absorbed how much effective light. So this action spectrum is basically used to check the effectiveness of the light absorption to drive what to create the photosynthesis or to drive photosynthesis. So here action spectrum is basically used to tell like action spectrum is the spectrum where maximum photosynthesis take place in this spectrum. So here I'm going to draw one. We can say this action spectrum was first discovered by Engelmann. Engelmann. Fine. So here you can see this is we have one. Here we have the spectrum. Okay, and from here the visible light comes. Visible light. Here the visible lights come. This is the prism. So from the prism, from the visible light, we get the 7 colors, 7 different colors. Those were Vibgor, 5, 6, 7, Vibgor. Okay, we got the 7 different color Vibgor. So here we put one alga. That alga name was Cladophora. Here one alga was placed. This was the alga that was named as Cladophora. This is alga. Okay, and here we were having some organic bacteria which was aerobic. Organic bacteria. Okay, so when this light comes, these mostly of organic bacteria, those were being here. Means mostly the organic bacteria were combined or arranged on the web and or color. The web and or color. Mostly the organic bacteria were combined here on the web and or color. So here we can see web and or are the 7 different colors which absorb the maximum absorption. Maximum absorption. And if I talk about here GY, which is green and yellow color, these absorb the minimum absorption. Minimum absorption. Fine, so here I'm going to draw the graph with the wavelength and rate of light, like which pigment absorb how much light. Here I'm going to draw the graph. This is VA wavelength. Here we have some wavelength like 400, 300, 200, and this will be in increasing order. 400, 450, 500, 550. So this is the wavelength, and here we have the rate of reaction. So the 2%, 4%, 6%, and 8%. And this is what rate of light. This is rate of light. Rate of light. Fine. So here from this the graph is formed like this. Okay, as I told you, like here we have seven different colors. So WIP which absorb the more maximum, while GR which absorb the less, while again that absorb the more, we can say wavelength. So this basically the space between two peaks is known as valley. The space between two peaks is known as valley, and this is the peak. And this is the peak. So here we have the absorption peak is narrow. Absorption peak is narrow. And this is the Borden Valley. Narrow peak, Borden Valley. The graph, this is basically this show the chlorophyll A, and this show the chlorophyll B. Now, here we can see the action spectrum of chlorophyll A in very detail. So let me draw here. So let's discuss about chlorophyll A action spectrum here. Spectrum. Fine. So this is what I'm going to draw. Here, this the chlorophyll A will absorb the more light. However, then we have the less. Then we have another. So this is the Borden peak of chlorophyll A because it absorbs the more wavelength of light. And this is the narrow valley. Narrow valley. Okay, due to accessory pigments from this chlorophyll A, the electron will absorb. So this is what the graph of action spectrum. Here the most important MCQ arises, that is basically like from the accessory pigments give electrons to the give energy to the chlorophyll A. So from chlorophyll A the electron excite and move to the electron transport chain. But how in the accessory pigments electron give? Here as you can see, here we have the accessory pigments, and this is the reaction center where we have dimer of chlorophyll. Dimer chlorophyll. Okay, and these are we have the accessory pigments. So here we have the accessory pigments, those are chlorophyll B, and here we have carotenoids. Here we have xanthophyll. Xanthophyll is not commonly, but we can write xanthophyll. So this accessory pigments give energy like in the like here like this. First of all, carotenoids give energy to chlorophyll B, and then chlorophyll B give energy to chlorophyll A, and from A the electron get excited. So this transfer of energy in the accessory pigments that is known as resonance energy transfer. Resonance energy transfer. I hope this action spectrum is clear to you guys. In the next video we're gonna see about the photosynthetic pigment. So bye bye.